Hello, on our continuation of why a scroll compressor can run and not pump. The first section we talked about the floating seal and its effect. In this section we're going to talk about the temperature protection that's in the Copeland compressors. The first one that we're going to talk about is the ASTP, or the Advanced Scroll Temperature Protection, like I have on this first slide that we're showing. If you see that label on the compressor, they are serious about that. The compressor may stop pumping with motor running, turn off and wait till cool, may need more than 1 hour to reset. Remember, like we mentioned in the first section, a compressor running and not pumping does not mean it's bad. And these are the following models that have had that temperature protection since October 2004. So how that protection basically works is there is a bimetal disc that is in the fixed scroll set, and basically when that temperature gets to above 220 degrees, that's acting like it's over 300 at discharge. So that bimetal will open, and basically that compressor will bypass that discharge gas off that intermediate stage. And kind of remember when we talked about the intermediate stage in the first section, talking about the floating seal, when that refrigerant or that pressure comes off, the floating seal will fall also. So the compressor will unload. So in the next slide, I've got the video, which basically goes through and explains the operation with a compressor showing that happening and then what happens to it.
Copeland scrolls use a pressurized cavity on top of the upper scroll in order to provide just the right amount of hold-down force to keep the scrolls together. In compressors with advanced scroll temperature protection, a bypass hole has been added between this cavity and the suction side of the compressor. A bimetal snap-acting thermal disc blocks this opening, similar to a valve. When this disc senses excessive temperature, it snaps open and allows the pressure in the cavity to escape to the suction side of the compressor. As the cavity pressure drops, the hold-down force on the upper scroll is eliminated, allowing the scrolls to separate. This stops compression and allows internal temperatures to decrease, although the motor continues to run. In other words, the compressor will run, but will not compress gas. Suction and discharge pressures will balance. To reset the thermal disc, stop the compressor and allow it to cool thoroughly. If the compressor is allowed to run, heat will build up in the motor, causing the compressor to shut down on motor protection. Keep in mind that the longer the compressor is allowed to run unloaded, the longer it will need to cool in order to reset. If you find a compressor that is running but not pumping, it is likely that advanced scroll temperature protection has activated. Do not assume the compressor has failed. Turn off the compressor and allow it to cool thoroughly, which may take a half to 2 hours. Then restart the compressor and verify that it is operating normally. In this example, watch as the internal temperature reaches 275 degrees Fahrenheit. The bimetal disc will snap open and the compressor will unload. Note that the pressures have balanced and the internal temperature is now decreasing. This unloaded condition will continue until the compressor is stopped and allowed to cool.
After we've seen that video, like they're saying, don't assume the compressor running unloaded is bad. There is a lot of misdiagnosed compressors in that range. So the other thing Copeland's done is on the smaller compressors, basically the 7 horsepower and smaller, depending on the design, they've incorporated a temperature-operated disc actually in the discharge of the scroll set. So I've got this slide showing, here's some of the models from that and giving you an idea of that protection. And that protection basically is rated 292 degrees approximately, and that bimetal will snap open. When that happens, there's a port drilled in the fixed scroll set. This one I have is a different design, but basically what happens is that port's drilled, and basically there's a little tube, and it comes down and it blows right on the overload. So again, over a period of time, that compressor running and not pumping, not moving refrigerant, will overheat and trip the thermal protector. So just like its advanced temperature protection cousin on the larger horsepowers, this compressor, the overload will reset, but the bimetal disc does not. And in this design, instead of having it in the actual discharge of the scroll set, they've got this design where they have a disc in the dome of the muffler plate, which basically would do the same thing. So hopefully this helps so the compressors won't be misdiagnosed and we end up with failures and we don't have an actual failure in a compressor. If this video's prompted any more questions, please contact us at uri.com, your local branch, or your United representative.